Gonna sneeze. Oh, this is important. Any mention? Okay, so oh my god, I don't really want to do this today. Oh shit. My hand hurts so bad. I shouldn't be programming today. Oh my god. So where is it right now? I think it's super broken now. Yeah, we've got a fucking black hole that I don't really understand where it's coming from. Fucking black hole. All of these black pixels means that it's stepping through all of the ray tracing steps, which is impossible. More or less. So it's really weird. Oh, Robert. So what is the problem? Right. Let's try doing this. Plus map position.x modulo 8. Well, that's really fucking promising. Holy shit. Did you ever figure out what that delta thingy calculating distance was for? Yes. More or less. So I think some of my values and calculations were kind of wrong before, obviously, but basically the delta distance should be the distance that it needs to travel. No, it was right now. The delta distance is the distance it needs to travel, or the ray needs to travel, before the x, y, z is incremented. So that can be pretty much any value, because it depends on how straight your line is. If it goes to the side or diagonally, both values are gonna be pretty low because they both increment often. But like if you're shooting a ray straight up, then the X value is not going to increment very often. So that's going to be a really high value, because that means that it has to travel that distance along the ray before it increments. And the side dist here, that is not entirely 100% certain, but it's basically the distance to the edge of the first voxel. And then from there, we continue raycasting. It's so that the rest of the values are right when you're incrementing, because otherwise you're gonna be... When you're supposed to end up inside a voxel, you'll always be like right in front of the voxel, and then it'll jump too far. And then the way it happens is that every single iteration, we check the side distance, and we check which side is the lowest right now. And whichever side is the lowest needs to have delta dist added to it. And that way we can tell, like at this point, if y is the lowest, then we add the y delta distance, and then we increment the y in like our index position, so that gets +1. And that's just how it works, and that's how you just like increment the ray as you go along. And it seems to work. I imagine, like, I feel like there should be some inaccuracies there, but maybe not. Anyway, now we need to figure out what to do. Fix this new issue. I'm a little bit lost on that. Let's see. Posted the code a little bit all over the place, and I'm trying to... I made a lot of changes yesterday, and I don't know what I might have fucked up. Could this be 7? I don't think so. If we think for a second, if this is modulo 8, that means that once map position reaches 8, then it becomes 0. And that's how it should be. Check your app out. How about check out this band? But then I don't need this, right? This should be superfluous now. God damn it. I don't understand this. This is super, super weird. Because it only goes black if we go outside of... No, not outside of the world. It only goes black if we go... here. If the step limit goes... If we go past the step limit, and my step limit is 500 right now, which is super high. So the fact that it does that is super, super strange. But maybe it's... maybe nothing is getting incremented here right now. For some reason. So here, brick map position, that should be set to map position divided by 8. So if the map position is 12, then that becomes like 1.4 or something. And then that gets floored to 1. So then we know that we're at brick map position 1. And then the mask gets incremented, or the map position gets incremented by +1 based on the mask. So then it goes from being at 1 to being at 2. And if we are at 12, say, what happens is that I multiply the brick map position by 8, so we went from 12 to 16, right? So 2 times 8 is 16, so that's our new position. I wonder if I still need to do... Let's try adding this here. Because I imagine it might still get weird. Because right now I'm just doing it with all of the directions at the same time. So let's just add a times mask here, or times load int mask dot x. Z y. And then we need to change this to max again. And now we're back to it not working fucking at all. That's not fun. But black is even worse. That means it doesn't work at all. But I don't really understand why it doesn't work at all. Because the idea here is that this gets set by dividing this, right? And then we multiply it back up again. Then what we get is the bottom left corner of the brick that the tile is in, or the voxel is in. And then we add the map position using modulo 8. And then it'll give us a value between 0 to 7 and add to it. So if we're at 12, then we divide it by 8, floor it, multiply it back up again. Then we have 8. And then it adds 0, 1, 2, 3. And it adds... Oh, is that what makes it weird? No, because if it's at... No, it's right. If it's at 0, then we add 0. And if it's at 1, then we add 1, and it goes from 8 to 9. So that's just keeping the position where we are. But now that I think about it, this will be 0 anyway. So this should still be max. But this isn't much better than what I had yesterday. did I do? It looked okay. We've only made it worse since then. I don't feel like I've done anything. See, this is where it's okay. Like, the further away we move, the worse it gets. And we still have infinite traversal issues here. But only in this direction. I do know why this happens, kind of. Fuck's sake, dude. So tiresome. This is wrong. This should not be here. Because the whole point of this is to add or remove 7. Depending on if we're going left or right. But this already fulfills that thing. So, like, all I should have to do is just get rid of some of this. I don't think this is gonna work, but I'm just testing a hunch. But the ray is obviously bending. Like if you look, it's actually kind of showing the right thing. It's just kind of getting further and further away and like bent away. That's more or less what's happening. And the white we see is that it's like seeing the top of it instead of... So the ray just travels too far. Somehow. I believe. I was trying to like add a fraction of the delta to the brick side disk, but because we don't, from what I understand, it's not that we're always at like the middle of a voxel or something, because there is a differential somewhere in here that you can extract that tells you like we are at 0.3 of this voxel's left side, for example. But and that's what I was thinking, that maybe that's what's causing it somehow. But it really shouldn't, because we're just because we're skipping a brick. So it kind of might be. Maybe we should try adding... Makes no sense either. I was just thinking like we could just add 8, pretty much. And then just kind of see where we end up. But if I do that, that makes no sense because no, it makes no sense. I don't understand why it doesn't work. This is so fucked up. Why? We add the screen position. We set the camera direction. Camera direction is minus 0.8. That is basically the FOV, as far as I understand. Makes no difference on this. Ray position is the camera position. The ray direction is screen position X times camera plane U, which is times 1. I don't know why they do this. This is so weird to me. I think they literally just multiply the screen position into camera plane U so that it becomes a float 3 with camera with the screen position there. That's what they do. And then plus screen position Y times camera plane B. But this is fine. Because the thing is, everything that works when we're just raycasting the voxels is that's like confirmed working, right? It's literally only the second we start dealing with the bricks, it just breaks. And I don't understand. Delta distance. Abs, float 3 length, radier, like these two are exactly the same. So these are the exact same values. I just have them there for the logic. Ray step is sine ray direction, so that's gonna be +1 or -1 depending if it's a negative or positive ray. Map position is floor ray position, so that's where we're standing right now as integers. And the brick map position is the same, except it's ray position divided by 8. Because if we are at 5, that means that we're at brick 0. So we divide this by 8, floor it. And that's our brick map position. And then this is where things differ a little bit. Side distance, that is based on just map position minus ray position. Because we need the differential between the floored version of the position and the ray position, to get the value that we're just adding in the beginning. so that we're correctly offset. And then brick side distance does the same. Now, this is what I think might be wrong, but I don't know. It shouldn't really be. Because my idea was just that we raycast the voxels, and then when the voxels go over into a new brick, we keep track of that. It increments the brick side distance as well, right? And it increments it by like the last direction we traveled. That's where the brick side distance increments as well, because that'll always be the case. Like if we move to the voxel to the right and that incremented the brick, then that means that we increment the brick to the right. It's that simple. But I'm only doing that on the side distance here. The map position for the brick map position is just calculated based on the map position, which should be fine. We should be able to do the same thing for the brick side dist as well. But I don't see how it's necessary since I'm doing this. I'm incrementing map position. Because what I do here is we check for a new brick. And then we see, is the new brick the same as the last brick? If that is false, then we check if we need to traverse the brick. That's where we check for the brick mask. And we check if the brick needs traversing. If that returns false, then we just go here to the brick map code. Otherwise, we go in here to traverse brick. And I mean, this works, so it doesn't matter, really. But we check for the voxel here, and if the voxel is true, then we return based on the mask from the previous step. And the mask is which side we see. And here we set mask based on less than equal on the side dist, increment the side dist, increment the map position, set the old brick to the new brick, and then we check the brick again. And if it now again is not the same, then we increment the brick side distance. And now we don't do brick equals new brick again, because now this is false. We know that we've found a new brick now. And then this just iterates, and then we go back here, and it checks new brick again, even though it doesn't need to, but that's what it does. And then, if new brick does not equal brick, then we again check for traverse brick. And if that is again true, then we just go in, like... I don't see it. I don't see where the issue is. And here we traverse into... We check this, right? New brick equals get brick. And then we see new brick does not equal brick. Then we increment the brick side list. And we go back here and we check if new brick does not equal brick. And that's still true. Or that's still false, rather. Then we check the brick again. And then we find another brick mask. Or another brick that we need to enter. Then we go in. And then we set brick equals new brick. Because that way now we know that we have entered this brick. Then we check the mask. Less than equal brick side list. And we've already incremented that here. So this should not need doing anything with. We should be at the correct place. And then based on the mask we get here, that's going to be the direction we increment brick side list. So then we increment brick side list. Then we set brick map position based on the map position divided by 8. Then we increment brick map position. Because now we're checking the current brick, right? That's what's happening. We entered a brick, and then we checked the brick, and we saw there's nothing in this brick. Skip it. And then we're in here now, and we're incrementing to the next brick according to the less than equal method. So the map position gets incremented by mask times ray step. Brick side distance get incremented by mask times delta dis, like it's supposed to. And brick map position is map position divided by 8, floored plus 1. And that'll give us the other side of whatever where we were at. Right? And then new map position is brick map position dot x times 8. So since we were at brick map position 1, we incremented that to 2. We multiply that by 8, and we add the map position modulo, which is like if we were at 7, then 7 gets added because that tells us that we were on the other side. On the brick. And that's mostly useful for going to the left, because otherwise if you're at brick 2 and you're moving to the left and you increment it down or decrement it, and you just check against that new position times 8, now it's like we have traveled to the left side of the new brick, to the left, and that means we've traveled 8 voxels too far. So it needs to add the map position differential. Wait, does that work? No, that doesn't work. Because when we're moving to the left, we're at 0 when we enter to the left. We should need this back. How should I do it though? Wait, hold on. I'm thinking. Maybe I'm wrong again. So we're moving left, right? When we move in here, we are actually, if we move to the left, we actually went from brick 2 to brick 1. That's what triggered us being here. So that means that we're standing at 7 right now. And that divided by 8 floored, that tells us that we're at brick 0. Or let's go with brick 1. We're standing at 15. And what happens then is that the brick gets standing at 15. That gets translated to brick equals 1. And then we're again iterating it down to brick equals 0. Right? So what we're trying to do is we're trying to skip this brick and end up in the next brick. Another one sign. And then we end up with 0 times 8 plus modulo position modulo 8. And that'll give us a 7. Right? So it actually does work. It did work. I don't have to do this again. I'll be right back. Can we manage something like this? I mean, the thing is that the delta dist and the side dist, they're all normalized values. It doesn't matter how large the voxel is, because the brick map is a voxel. All we're getting is just like a normalized value here. I'm just trying to think of it as two separate rays. Kind of. One high resolution and one low resolution. But I can't make it make sense with why it doesn't work right now. Because all the values should be correct. So what's wrong? Driving me crazy. Because all I'm trying to do here is just increment this ray. And I'm incrementing this, the traverse brick section. Here. If we open this thing from yesterday. To get here to 8.2, that's two steps, right? So all I'm doing is I'm figuring out where we end up, which is at 8. And then we subtract 6 from that, so we get 2. And then I multiply this by the delta values, the delta dist. And then we do some thingies, and then yeah, we take 8 minus 6, that's 2, then we multiply that by the x delta dist. Then we get the distance traveled. Then we take the delta dist on the x and the y, and we divide that by this value. That way we get a distance or steps taken in each axis. And that's going to be 2 in this case on the y. And then we add 2 to the y, and we add 2 to the x. And then we're where we're supposed to be. So why doesn't it work? Like, I'm even adding the exact same steps, just like if we had moved over there. So why doesn't it work? Like, it's correct. That's what's so frustrating. Tell me what's wrong. Fix it for me. Where are all the ray tracing experts? I'm gonna rename the stream to "Help me fix my ray tracer." Please. There we go. I have pulse differential. And only one of them has changed. So it's gonna be 0 in all of them except for one. So we multiply 0, let's say 3 and 0 by delta dist. And then we get the distance traveled. And then we extract that using the max setup down there. So then we have the distance traveled. And then we take distance traveled divided by delta dist. Right? And then we get the distance traveled. We get what we need. Like, it's correct, so fuck you, dude. But you can tell it's not. You can tell where the brick is. This little line here, that's the brick. So if I'm looking over there, that becomes inaccurate. But why? Because it's still reading those values up there. And like the closer you go, why would that happen? No reason for this. The roof doesn't show anymore either. That's also really weird. The roof doesn't work. For some reason, the roof does not work. That's really strange too. Maybe that's a clue. I don't think so. See, here's the roof. But the roof doesn't show at all. Like nothing. So it's like it's not correctly exiting you. Or something. How can that be possible? How can that be possible? Like, fuck you! Fuck off! The only thing I can kind of maybe imagine is that For some reason, we're getting like incremented too little, so it like it. I don't fucking get it. Maybe the issue is up here, like with the get brick or some bullshit. No, that's correct. That's correct. There's no issue with the get brick. And the check brick mask as well. Like, there's no problem. Wait, hold on, what's going on here? Is this the problem? This could be it. What is happening here? Nice fix, bro! So cool, it doesn't fucking work. But I'm pretty sure this was wrong. Bit index. Is there anything else I fucked with just now? Not really. So that is traverse brick equals false. Now this is still wrong. It needs to be... Should it be like this? I think that should be right. Fuck you, piece of shit, bastard, asshole! Fucking cunt! Oh! However, we can see the roof now. The roof works now. That's one step forward. Let's see. The math might still be wrong. So... No. I'm quite sure it's right now. Oh, Mistra. It's a DDA ray tracer. It actually works the way it should, kind of. But I'm using brick maps, if you know what brick maps are, and I'm trying to skip space where there's nothing in the brick maps. Sparse volume thing. But I can't get it to render the other side properly. I just found a bug that I thought would have solved it. It's a compute shader only. Well, I mean, it's a compute shader that I render on a quad. Ooh, so what I just fixed was where I check here, check brick bit mask. I have a bit mask for every brick map. Every brick map is 8 times 8 times 8 voxels, and so what I do is no RTX. Yeah, no, I'm just trying to literally draw voxels on the screen instead of using meshing. I'm just trying to ray trace on the GPU. It's for rendering. I guess it's technically ray marching. So I see different ways to describe ray marching as well, but every brick has 512 bits assigned to it, and whenever a voxel is set to contain something, that mask bit is set to 1. So what I'm doing is when I enter a brick, I go in here and I iterate through 16 uints, because that's 512 bits, and I just add them all to an accumulator. And then I just check if is the accumulator 0, then the brick is empty, else true. And then we just go in, and it works. Like, that clearly works now, because before I was having issues where I wasn't able to even see the ceiling, for example. But like here, there are voxels, so it's returning true, and there the rendering works. But once we enter the place where there are no voxels, and it has to traverse to the other side and find whatever voxel is there, it goes to shit. And what I'm doing is we're just taking the screen position, which is the ID of the blue is whenever a ray hits outside of the bounds of the voxel array, basically. Then I return blue for sky. And if it returns black, that means we are at the end of our step limit. And then it just returns black instead. But it's basically this. Let's see. No, it shows the beautiful blue sky. But it's basically that code. And it works. It works perfectly, except for the bricks. but we get our ray direction, we multiply it by the camera, we get our delta distance by doing this. I honestly don't understand the math here. We get the length of the ray direction, and then we divide it by ray direction, and then we get our delta distance, which is how far the ray has to travel for that axis to increment. And then we have ray step, which is just the sign of the ray direction, so if it's a positive or a negative ray. Map position is just where the ray started off as an index. I actually kind of want to rename ray position, but whatever. This should be ray origin. Brick map position. So this is where things get a little different. The brick map position is... it's just a lower resolution array, right? Like the map position, that's an array of voxels. But the brick map position is the same array, it's just lower resolution. It's just 8 times lower resolution. So I take the ray position and I divide it by 8. That way we get a 0, for example, if we're at like 5. While map position would be 5, because this is the first brick. And side dist, from what I understand, is side dist is when we need to offset our whatever position we have in the first brick or first voxel, we have to offset that so that we can properly ray trace to the intersections. And here I'm also doing the same thing here. The brick side dist is different because we have the brick map position minus ray position divided by 8 instead of just minus ray position. That way we get like the 0 to 1 offset that we are inside the thing. Then we go into the ray tracing loop, we check if we're in the world. If not, then draw sky equals true, and we just break the loop, and then we go and we draw the sky, which is blue. Then we check which brick we're in. We set new brick to get brick. We have another brick here called just brick, which is set to 0 in the beginning. We check if new brick does not equal brick. Then we go in here and we check traverse brick. And that's where we loop through the brick mask, or the brick bit mask, and see if we return 0 or any other value. If we return any value, then we enter the brick and we iterate through it until we find a voxel or get to the end of the brick. And when we get to the end of the brick here, we also iterate the brick so that the brick ray tracing should keep up, in theory. Hello, Jamwar. I'm terrible. Thank you. And here we just iterate. The way it works is that we check the side dist sides against each other, and whichever is lowest gets incremented. And then it gets incremented by the delta dist. And this is where the higher the delta dist value, the less often that side gets incremented. We increment the map position based on the boolean. This is a bool 3. And that's what we get here. We get which side is incremented. And then side dist is incremented by that value. And all of this works just fine. Until we get down here. So this is when we get to here, we increment the brick. And I don't have a computer except a school one. Alright, dude. Hello, Ludicrous Devil, how's it going? But once this brick gets incremented, then we go back up here and we check the brick again, and then this time it's gonna say no, there's nothing inside, so just go down here. So we set the brick to new brick, which means that we have checked this brick. And then we check the mask of the brick side list, which is kept up to date here, right? So that should make sense. This will tell us that, okay, now we need to, like if I open this, laser beams in your eyes, but basically once we go over here, over there, then the side disk gets incremented to the right, and then the math will know, right, that the next brick that we need to exit through is going to be up. So that's what it gets set to. It just knows that. Or it's supposed to. Then we increment that brick side. And then here we set brick map position to be the map position, because we keep setting the map position here. Divided by 8, that way we get the brick. And then we add this step to the brick map position, right? So now we've iterated that. And then here we have a new map position, which is the iterated brick map position times 8 plus map position modulo, which gives us, like, if something is at 5, like the y is at 5 and we're iterating the x, then we keep that 5 there. And the same if we're going to the left in x, then we enter into 7 on the previous brick. But the brick map position is starting at the left, so we add the 7 so that we know that we're at the right side. And that gives us our new map position. And then we get the differential. It abs the new map position minus map position. And then I multiply that. This is because two out of 3 values stayed the same. Only one of them got incremented. So that means we only have one axis that has anything in it. The others are 0, right? Or is this where it's wrong? What happens... What happens when we're moving to the left, for example? No, they're both always going to be positive values, so we'll always just get a normal distance. Yeah, so this is just a distance, and then we take the distance that we just got, multiply it by our delta distance, because the delta distance is how far along the axis we have to travel to increment once, right? So let's say we multiply that with the y distance here. Then we get how many steps we've taken, or how far we have incremented along the ray here. And then we have to extract this here by doing a max against all of those axes. And then I take this value that we just got. This is how far we've traveled. I set that up as a float 3. And I divide it by our delta distance. And floor it. That way, if this is like we've traveled 3.546 or something along the ray. And we divide this by delta distance, and the x delta distance is like 4.8. That just results in 0. So we've incremented x 0 times. If z is like 0.5, then we incremented that like 8 times. And then I just take that, add it to the map position, multiplied by ray step, so that it becomes negative if it's a negative ray. And side dist, we just add delta dist times the amount of steps we've taken here. And it should just work. Like, it's correct. But, in my opinion at least. But it just doesn't want to work. And I don't get it. There's gotta be something minor that's wrong somewhere. But basically everything that works in the voxel resolution, or the voxel stage here, everything that works here works. Like, it's confirmed it works. So it's just something down here that's wrong. And I just do not understand. And neither does anyone else. This was like my last hope. The fact that I found this and this was wrong. This was my last hope. I don't get it now. Why true false? Because otherwise it ends up like this. But what this does is it checks all the axes against each other, and then, or it checks the x against the y, or the, you throw in I'm not that advanced of a programmer. I don't even know what that means. I'm just trying to get it to work. I don't know. Can you just set it like this? Alright. Didn't know that. Get brick. But this works. I've already confirmed that this works. Because I've many times flown outside of the world and painted these a red shade based on the get brick value that we get. And those values are right, so this is confirmed to work. Get voxel. Looks like it should work. Check brick bit mask. We give it a brick value. And that's a brick index. And then we multiply the index by 512 because that's how much we have. And this here we have a step that's unnecessary. We can just do that. There. We can floor it just in case, but since it's divided by an integer, it shouldn't matter. I don't know if this needs to be cast to a uint since it becomes an integer there. Maybe. I'm not sure if it does. So yeah, I guess it returns a float. I wonder if that's causing any issues anywhere. Yeah. But basically, the bit masks are all 32-bit uints, and so I take the brick index, multiply it by 512. And we divide it by 32. That'll give us a value between yeah, if the brick is 1, then this will give us a value of 16. Because each brick has 16 bitmap uints attached to it. So then we use our bit index here, and we set the for loop to loop from our bit index 2-bit index plus 16. And for every bit mask that we find that... And here I guess we can do the same. We can just remove this. Well, if you have 512 divided by 32. Then you get 16. And the reason for this is because the 512, that represents the voxels, right? And we have 1 bit for each voxel. So that's why I divide it by 32, because each integer has 32 bits. So I divide it by 32 bits, basically. And then we get 16, which is the first uint that contains the first set of 32 bits. And that's why it's plus 16 here, because there's just 16 bit masks per brick map. Exactly. So we iterate through that, and we add that to the accumulator. And then we return accumulator equals 0. Okay, so if I want this to return false, then we have to do accumulator does not equal 0. Then. Hello, cool crawler Pongao, how's it go? So now if accumulator does not equal 0, it returns true. And here we do get bit mask. And here's where we do the same thing here, kind of. But we're only getting a bit from a voxel index. So we do the same thing. So here we divide voxel index by 32 float. And then we floor it, convert it to uint, and add it to a bit index. That way we get the uint that we need to access. And then here we have the bit remainder, and that's the original bit float minus bit index. So then we get the decimals, and then we multiply that up by 32 again. And I'm rounding it there, but I don't think we need to. And then we get the bit that we need to get in that integer. So we access the bitmaps using the bit index, and then we use bitwise to shift the bit remainder to the right, and then we do an AND check versus 1. And then we just either get 1 or 0. And that tells us if there's something in the voxel or not. But all of that should be functional. It's just, I don't know. Like, I don't know where to go anymore. Bitmaps is a buffer, but bitmaps.bitmask is uint, yes. The structured buffer that looks like that. What did I just break? I don't remember what I even did before we did all of this. That? No. Wasn't that either? It was that. Because I removed the float? For the round? I wonder if the error could be in here. Because this is how I check if we need to draw or not. So it could be this, somehow. That this is getting the wrong value. But like, subtracting a uint from a float, that shouldn't convert the float, right? Or maybe it does. No. You subtract int from float. The int gets promoted to float automatically. Right. Yeah, that's what I thought was strange. Like this should be fine. No reason for it to be an int though. Why round? I don't remember. It's because the value is going to be close enough always. I think I only did it in case of rounding errors. Let's give the math a try, I guess. Like voxel index is gonna be 18, 2, 3, 5, like literally this. There's a gotcha here, divided by 32. What's the gotcha? 18 to 346 divided by 32. And then we floor this. To that. And then bit remainder equals uint round 5698 times 3125 minus 5698 times 32. Which is 0.3125 times 32. And then we get 10. Well, I already did floor here, and it doesn't make a difference. But that's definitely, we can... can just do that in case we need to go back to that, but neither works, right? And then we get the 10 there, converted to a uint. And so then we have bitmaps, and the index is 5698. Dot bitmask pointer 10 and 1. Now here I'm not sure about the types here, because like this is an int and we're doing an and this is an int. Well, no, this should be a uint. And I don't really know about this. That's why before here I was casting this to a uint. But I don't really know. I don't use this that often. But basically, I don't think you can do those. Oh, you can? Okay. I kind of gave up on that because I couldn't do, like, you can't do F or D. You can't do a, I don't know how you even type a double. Okay, that's good to know. The only reason I'm confused or a little bit unsure was because in C# it can complain about this. And there you have to cast things. But even so, it still won't work, so... Like, we still got this shit. And it's driving me mental. But it works better now, because before I couldn't even see the roof, but that was the bit mask check. But let me do this. That makes it easier to look at least. But it's this, like, it's this part that's doing some bullshit. It has to be. Like, the only other way is that check voxel is doing something wrong. And it's not getting the right voxel. This is how I'm doing that. I'm using our X position with a modulo 8, our Y position with a modulo 8 times 8, plus position Z with a modulo 8 times 64, plus the brick times 512. So that will give us the local X, Y, and Z position within the current brick. The only reason I did that was because they were doing that in here, I think. Yeah. See here, they do map position plus equals IVEC3, VEC3, mask, ray step. But in HLSL, it might not matter. GLSL seems a lot crankier when it comes to like casting and conversions and stuff. And this is GLSL. So those floats to ints are probably unnecessary. I don't think they make a difference, but we can try fixing them. Oh, there's a difference? Yeah, I've never tried GLSL. But you can see I'm already doing without the weirdo double cast here. Alright. That's also unnecessary. But also doesn't fix anything. Oh. But it's working a lot better than it did before. I've been stuck on this for like 2 weeks now. And I've been doing it every single day. We've made a little bit of progress, but it never actually works. But like, I can do this. If we just go here and we get rid of the traverse brick check. Then it works. That is because the map is too big, so it's running out of steps. That's why it's black. But like now it works just fine, right? So the ray tracing itself, it works, but like there's just something with the skipping code. And I don't know where to go from here now. Oh. What if we do this? No difference. But like you can see that there's just something that's just not right. And again, I feel like it's traveling further than it should. That's what's happening. Because if you go in and you look at this, it kind of looks like it's going in a curve inwards. And just don't really see it. There's gotta be some silly miss somewhere. Wrong order of bits. What if we do bit remainder at 32 minus bit remainder. That makes sense, or should it be 31? Maybe that's not enough. But again, this works. That's the thing. This works. Have to remember that. Because the only time I'm checking this is in here. When we find a brick that has voxels in it, we go in there and then we check for the bit to see if it contains a voxel, and then we just break. But that works. It's only when the brick skipping is included that it doesn't work. So it could potentially still be something that it's counting the wrong brick or something, and it's checking against the wrong brick. But I don't understand how that would really happen. Because the brick is checked against our map position. And yeah, this whole else section here in the bottom of the raycaster, that's meant to increment a brick instead of a voxel. And then based on the distance traveled, I increment the other values as well. Or the other axes. This is the crux of it. But we've already found plenty of bugs outside of this, so could be something else. You don't get it? Well, it works like this. I mean, maybe you don't understand because you have a better way of doing it, I don't know, but the first brick contains 512 voxels, right? So we give it a brick value. Brick equals 3. And then we get our voxel index by doing 3 times 512 equals 3 times 512. 1536. 1536 divided by 32 equals 48. So this is the index of the first uint bit mask for that brick. Right? So we have 48 there. And then what we want to do is we want to know, should we skip this brick entirely or not? And to figure that out, we have to know if all of the voxels are empty. And the only way we can do that is to check all of the uints. So, because if any bit is flipped in a uint, then it's no longer 0. I think there are overflows. Well, we can try. We can just do... We can just do like this. I think it can overflow. I think you're kind of right. Because if the yeah, you're absolutely right. Because we're still checking the brick bit mask. But you're right. If you do or equals, then it can't. That's a good idea. Maybe that's what we've been having the whole time. Nope. But you are absolutely correct. Because all it takes is like literally 4 rows of voxels. And if those are full, then the uint is full. And then if I try adding another one, that's an overflow. Fortunately, like, see, it's so annoying. I just keep finding things that are wrong and fix it, and it still does nothing. Say that. Like, I don't know. Yeah, I feel like we are... Yeah. It absolutely suggests that, but I don't understand where that would happen. What if we change all of these to use? This is called desperation. They are the same. And the reason for that is that I kind of just put them there to make it easier in my brain when I was building it, but brick delta disk can be removed entirely. But otherwise they should be the same, because it's not a literal distance, it's like a normalized distance to the edge. Or to the next. To the next axis change. Well, yeah, to the edge of that axis. This is like the only thing that I can think of that could be doing something, and it's the brick-sidedest. Because here, this offset on the brick-sidedest is different, but it shouldn't matter, because it should be like that, in my opinion. It's just the distance to the side from where we are. And it's just so that the rest of the iteration logic is correct. Well, you and me both. I should take a walk anyway. You helped a lot. But unfortunately we didn't solve it. But there's probably still just something silly in here. I just don't know what it is. But this probably saved me from future headaches. Maybe. I'm not sure. I'm not sure how it handles an overflow. Like if it literally just discards it and just like keeps it maxed out or what. Because it still works, right? Even when this happens, it still worked on the bricks that had voxels in them. Yeah, so it shouldn't really have mattered, unfortunately, but need that there, it doesn't matter though. All we need is like something being wrong, right? We can try this. This should be incorrect. And it is incorrect. Well, how about I go for a walk and then we get back and then I don't know. Like I'm at the end of my rope here. Could I share you some bits in these tiring ray tracing times? Thank you. Oh. But I'll be back in 20 minutes. I'll keep the stream up. I'm just gonna take a walk around the block just to reset my brain. Hold on a sec. Alright, holding on. I wish there was something more tangible to really figure out what's going on. But it's not like an issue with the negative rays or positive rays or anything like that, because it looks exactly the same in all directions, so it's something else. Walsh matrix. Entries of the matrix are either +1 or -1, and its rows as well as columns are also blah blah blah. Yeah, kind of. I don't understand. How something like that can happen. So I'm not accessing anything here, right? Like the only thing this part does is it just increments to the next brick. And then we extrapolate how much we need to increment the X and the Y and the Z based on the difference between where we are now and where we were. And like there still has to be something here that just isn't right. Because again, drawing the voxels works. So The only thing I can really imagine is that we're just not incrementing something enough. Like we're missing one step or something like that. That didn't help. This doesn't even need to be split up like this anymore. I can just do brick map times 8 map position modulo 8. I don't think I can do that, because the minimum step is 1. I mean... I was thinking... Just try this. I had considered here, in the voxel steps, where I'm stepping the brick grid when we enter a new brick, I had considered doing something like just this. And then instead of adding the delta dist, we add delta dist divided by 8. But I don't think that ends up with the correct values that we want. But, knows. Fine. Oh. However, it does iterate it faster now. Like, it is different. Alright, dude. Thanks for the help. Have a nice rest. I'm gonna take that walk. I'll be back in 20, 30, something. Ooh. You're back. And did I think of anything while I was taking a walk? Absolutely not. And add an and here. Z modulo that is it's so annoying to draw. Ugh. Let's do if BZ is greater than brick grid size divided by 2. Or the X is greater than brick grid size divided by. Let me do that, else voxels E index equals new voxel 2. But yeah. This wasn't how I wanted it to draw, but that's good enough. I mean, it clearly shows that we're drawing the axes on the right side. So it's not like anything is flipped, really. But what's happening there, where we see the white stuff, is, I don't know. What? Yeah, I don't know. Where is that coming from? I thought it was an air voxel, but since it's not updating when I update the voxel color, well, oh yeah. If we do this, yeah, it is the air block that it's drawing. So it's drawing an air block using the incorrect check. So it's checking something and it's returning an incorrect value. But that doesn't explain the bends, really, does it? But if there was anything wrong with check voxel or get voxel, then the normal raycasting wouldn't work. So it still has to have something to do with the incrementation. Like at this point, I'm quite confident that whatever we're doing up here is correct. Hello, Light. Did I ever get a video card? What? I have gotten video cards. What specifically are we talking about? No. I have a 1060, 6 gigabytes. Probably bad according to your whims, but I have no desires to get a new one at the moment. I've had it for a while. This isn't used anywhere. You... So what broke it? This? No. Something there broke it. But what did I do? I changed map position to uint, brick position to uint, ray step to uint. Oh, that's why. That's why. That's what broke it. I am basically flat out of ideas, other than just deleting this and just trying something from scratch, which is gonna end up exactly the same. I don't know. Like, there's something I'm missing, and I don't know what it is. You can see the edge here of the brick above us. You can see as it sways over. The brick can only show straight ahead properly. Kind of, but even that's broken. And then everything to the sides, it's just weird. Can't really figure out what this might be either from just seeing this. And nobody, like I posted it in multiple discords, but nobody's even responding. I don't get it. I think we'll stop there. I don't know. There's just no more things I can do. Yeah. I've done that like 7 times now. That's the problem. But I'm clearly not stepping the correct amount of times. And the reason you know that is that we keep getting air blocks. So it's kind of weird that we keep getting those air blocks, but we don't get, like, the air blocks have, you get the air blocks with all kinds of sides. Like, you can tell if it's dark or if it's mid or if it's bright. That's the X, Y, and Z mask. But that never happens with the green, the correct voxel. So that's like when you do an extra step or something, or we end up like in front of it. And it makes no sense. Because why would it draw these air blocks? What? Fuck off. Well, that solves the air blocks at least. But now we're instead getting green blocks where there were air blocks. But that makes sense there at the very least, but hello Lan, how's it going? Oh, good. Well, any progress? Yeah, but not enough. And now I'm just super stuck. I have no clue. I was reading my bit mask incorrectly, and now that I've fixed that, it's actually like drawing the sky or the ceiling. But as you can see, it's still just broken. And I just don't know. The only clue I have, and I don't even know if it's a real clue, is someone like this, wash matrix. And if you look at that, you can see that I get the same kind of pattern there as the wash matrix there. Or Hadamard matrix permutated into a sequentially ordered Hadamard matrix, blah blah blah. But how does this help? It doesn't. It's just like a small clue. But I don't even think this is part of it. I think all that's happening is that I'm just... I don't know. I don't know anymore. Can I make it work on a 2D plane? I don't know. I probably could, but that would be a lot of coding in and of itself. But the only thing I feel is that there might be something that needs to be like flipped or something. But I don't feel like that's it either. Because it works, like that's the thing. If I go in here and I turn this off there. Then it works. It's black because I can't see that far. But like here it works, right? And it's the optimization that's broken. But the logic checks out. But it still doesn't work. And that's why I'm losing my mind. Yeah, that's what's not working. Skipping the bricks. That's this part down here. There you go. Have fun. It's actually kind of weird. It doesn't work properly if you do that, but we can try here. We can't. This camera starts flipping around immediately. It's still, I don't know. Or if you mean like I don't know if I can get like an orthogonal projection here. I don't think so. Maybe. I don't know. I don't feel like it should be an issue. Maybe it is. Well, orthogonal wasn't that simple. I don't know, is it? Because it doesn't really affect anything. It's like it's a float 3 instead of a float 2. Like that's really all it changes. Logically. So, I don't know. If it really makes a difference. Uh... Well, I mean, I don't know. I'm not sure what you mean. It would still be stepping diagonally anyway. Just not diagonal in another axis. I just don't feel like the extra axis makes it really any harder. All the math is still the same. And it should just be something here that's just... I'm just overlooking. No, this is just a side project. Nobody knows anything. I've posted the code around on some Discord servers and I'm not getting any replies. Might try some forums or something. But we'll stop there for today. I can't. There's nothing more I can do. I'm gonna go and make food. Time for some pixel art now. Time to go and lie down in my couch and find another Chinese television show to watch. That's what's gonna happen. Anyway, thanks for dropping by. Have a good night. I'll see you guys around. Bye bye.